Hooray! Right near the end. It's pretty late, but excellent. I'm so pleased. We're right near the end. Now, this is a question 19, pretty tough. Okay, so I'll go through it relatively slowly. Well, you might think it's fast. I have my trusted friend Bonzo here, who's going to annoy me intensely. But let's just go with it. This is called completing the square. And there's various things you need to remember. So this is in the completing the square form. And the way you need to remember it is you look at these two terms only to begin with. Just look at these two. And I do this. I do x and I half the b value, that value, I half it like that. Okay? And then I square that. Now, if I were to multiply this out, so let's just do it to the side here, you would get this. If I multiply it out, that's what I would get. Very similar to this, except I've got a plus 9. So I need to get rid of that plus 9. And now I've got identical to these two. This is identical to these two. So I need to do, in order to complete it, add 1. And I've completed it. Okay? You just have to review this one loads of times. But that's all that you do. So it's x minus 3 all squared. Minus 9 plus 1 is minus 8. Just be careful you don't make mistakes. And they say a is 3, because I've helped you that, and b is 8. And that gets you your marks there. Now it says, hence, write down a turning point. Turning point, this is a quadratic. It's a happy quadratic. Happy days. And its turning point is where the gradient changes direction. And in this case, it goes from a negative to a positive. And at that point, everything is stationary. Everything is still. And we know it's still when you can't go any lower. And this tells us here, at this point, when x is 3, y is minus 8. You can't go any lower. And so that is there. So that is your turning point. Now finally, can't believe this. Come on, question 20. Oh no, we've got a question 21 after that. Oh my word, and a question 22. This is not the end. We've got another worksheet after this. Oh well, let's just go with the flow. Okay, so h is inversely proportional to p. We write that like this. H is inversely proportional to p. Okay, and that's the common language of it. Common, who speaks common language like that? And we write it in an equation like this. And it says that p is directly proportional, so we can have our value here, let's call that m, the root t. And we can say therefore that p equals m root t. Or why have I put the m there, silly Billy? Just like that. You can say it's late at night, isn't it? So I'm knackered. But anyway, given that h is 10, so here, if h is 10, p is 6, I can work out this constant value must be 60. So k must equal 60. In this case, it says when p is 6, t is 144, which is handy because I know square root of 144 is 12. So m must be a half. If you think about it, what do I times by 12 to get to 6? A half. So now I've got these two values. I can rewrite these. So h equals 60 over p. And I know that p equals a half root t. That's pretty good so far. Now it wants to know what is h in terms of t. So I need to substitute out the p value. Now look what I'm going to do. I'm going to put that up there because I don't like fractions to begin with. I'm going to do it like that. And then I'm going to put this value into there. Drop that into there. That's nice and straightforward. Thus getting rid of p. Now, I can times everything by 2 to get rid of the half. So I end up with h root t equals 120. And then I can divide everything by root t because I want it in terms of t, h in terms of t. So h equals 120 over root t. Hope that makes sense. I've got 2 more questions to do. Not too bad. Watch the next video for those.